Adam, does your icon represent something? The circle, hazy, limitless?
No, not really.
No? Okay, there's no math that goes along with it?
Nope.
No? Oh, okay. I like circles. They're limitless. You just keep spinning around and around, but then sometimes in life you go full circle. So you just thought it was neat, I guess, huh?
Yep.
Okay. Cassie, I can't ask you anything because you just have your name up, so you
Yeah, I'm just boring.
can... That's okay. Nothing wrong with boring. I think we're good. Looks like T-Go maybe. All right, so looks like we got about everybody with us. Last day to kind of talk about our prerequisite chapter, which I think you probably found that this last section is not a lot of prerequisite. I mean, the skills are, I'd say, but the process of solving an equality that isn't in linear form is definitely a little different. And we started to talk about that yesterday with the polynomial inequalities. And that's because a polynomial is a curve, and once you cut a horizontal line through a curve, we could have portions of the graph above or below, and you might have multiple intervals depending on what's going on with the function that we're dealing with. So we are going to kind of continue talking about solving inequalities today, those polynomial inequalities. And we will also look at solving rational inequalities. And we worked with rationals already this chapter. So those rationals that we were working with were simplifying, subtracting them together, getting that common denominator. Can you hear me?
Yeah.
Okay. So we're going to kind of look at that as well. So we're going to focus on inequalities today that are not of the linear form and try and solve them using the test intervals and the zeros of the function. So that's what we're going to kind of look at and wrap up chapter P. Tomorrow we will review. I have a review worksheet that kind of summarizes all the concepts in chapter P, which there were a lot. Spending, let's see, about 12 or 13 days on a prerequisite chapter. There's a lot of concepts. Figure we've been doing pretty much a new concept every day. So going back, we started with the distance and midpoint formula. We looked at those basic graphs and how to look at those basic graphs and get them to graph easily without making a t-chart. And then we did a lot of simplifying with exponents and the rational expressions. And then finally, we've wrapped it up with the equations and inequalities. So Friday, we'll start chapter 1. I'd say maybe just start looking over those notes if you get a chance tonight, kind of refreshing yourself what we did the beginning part of chapter P versus the end of chapter P. It all really spirals together, especially that factoring That kind of we learned, and then we're going to continue spiraling that through all of the chapters that we look at. So we're going to use the calculator for one problem today. So if you have that calculator by you, see if you can take that out, because we're going to try and just make sure we solidify that, like looking at an inequality in your calculator, what are you looking for to answer or solve the actual linear inequality? Just a little review, refresher from yesterday. We solved the first polynomial inequality by factoring. And then we took those x values from the factors and we created a number line, and we broke that number line up into intervals or ranges, if you want to call it a range, a section, whatever you want to call the word. And then we tested those intervals, doing a little algebraic test, picking a number that fell within that range and plugging it into the original inequality, because that's the part that we were truly solving for. So we were really solving for the part that was greater than 0 by dividing the number line up into these different sections. So we're going to try and do that again. Again, to kind of just make sure everybody's on the same page. Let's see another problem. It might make it go a little more smooth. And I actually changed this problem a little bit, and I know there's an 8 there. And I thought, to make life easier on us, instead of taking the square root of 8 and then having to simplify it and keeping a radical in the equation or in the expression, made it a little nicer changing it to a 9. So if you want to change your inequality in number 2 to say the quantity x plus 6 squared is less than or equal to 9, it makes the answers just a little nicer. And because I felt like being kind today, I thought we'd look at a slightly easier number to simplify instead of an evil square root of 8. Not evil, doable, but figured I want to worry about the process and not about the fact that we have a radical in an equation or a solution. So this is an inequality. It does say to solve, but remember, in solving, we're actually finding test intervals, or we're finding intervals. So the tricky part with math is to understand, what does the direction actually tell you to do? And that is dependent on the type of problem you're given. If it's an equation, I'm isolating x. If it's an inequality, I'm finding the intervals which hold the inequality true. So could somebody start us off with solving this inequality? What would you try and do first? So looking at like what we did yesterday up here, we factored. What do you think you would do first if in this type of problem? What would you traditionally do first if it was an equal sign?
You square root both sides.
Yeah, we would square root both sides. Good job, Michael. So we're going to take that and we're going to square root both sides. So sometimes the process starts out as being the same. Michael, when you take the square root of 9, since I changed it to a 9, you end up getting
3.
And what else do you get besides a 3?
-3.
Right, a plus and a minus 3, which means we have x plus 6 is equal to 3, and we have x plus 6 is equal to -3. So we have 2 answers. If I were solving for x, I'd have a solution at -3 and a solution at -9. But we're not solving for x. It's an inequality. So we're trying to find out intervals that hold this inequality true. Does anybody know what I would do with these 2 values that I found for x? So where do we go next? How do we continue to solve the inequality? Because it's not an equation.
Plot them on the number line, then you do the interval checking.
Nice job, Adam. So we're going to take those values and place them on a number line from least to greatest. So I know we've got a -9. That is smaller than -3. This creates intervals on our number line, sections, a range, however you want to word that. But now I have a portion that's divided up from -infinity to -9. We have another portion from -9 to 3, and a final piece from -3 to infinity. So again, we're not solving. Those aren't the solutions, but they create intervals for us, which will be the solution. And then once you have those intervals created, you're picking a couple of numbers that fall within those intervals and testing to see if they make the original inequality true. So I guess -10 would be a good number because it's just below -9. Maybe we'll pick a -2 in between -9 and -3. And then, I don't know, a 0 is always a good number to choose. Pick 3 numbers. As long as they fall within those 2 values, then you can use it to test that interval. So here's where the test part comes in. You take the number you just chose, you plug it into the original inequality. So I'm going to take the -10, plug it into the original inequality where it says +6 quantity squared. Our goal is to show that that is less than or equal to 9. I'm going to do the same thing with the -2, plugging it in. When we plug that in, does that remain less than or equal to 9? And then finally, using the 0, so pretty much we're testing to see, does this interval work for the inequality? If it does, then it's a solution. If it doesn't, it's not part of the solution. And it's pretty easy math here. We got -4 squared, which is 16. Adam, is 16 less than or equal to 9?
I don't think so.
I don't think so either. Not on a Tuesday, not on any day. So cross that off. The next one we have, we plugged in a -2.
This is Kane.
Yep, that isn't in between that interval, is it? No.
That's what I was gonna say.
Yeah. How about a 4? Does that sound better? A -4? Okay. So in plugging in a -4, because it needs to be in the interval, Mrs. Kane. A little brain fart there, I suppose. So we get 2 squared, which is 4. And as far as I know, 4 is less than or equal to 9. So that means this part is good to go, that middle area there. And then on the last one, we have 6 squared because we plugged in a 0. 36 is not less than or equal to 9. That one doesn't work either. So however you want to show that, you have to show some type of testing system to kind of prove, which you guys don't like that word prove, how about we say verify, that the correct interval or the given interval is the solution, the region to your inequality. So the last thing we need to do then is just write this as a solution. And remember, we're writing it in interval notation. We're finding an interval. Well, the first number in that interval is -9. The second number is 3, because in between those values will be where all of my solutions exist. And then we have to decide, is it brackets or parentheses that go around this? So do we have brackets or parentheses? Gabby, what do you think? Is it going to be brackets or parentheses around these two numbers?
Brackets,
Yeah, why do you say brackets?
because it's less than or equal to.
Exactly. So that symbol, less than or equal to, the equal to part means it's allowed to be those two numbers. Any questions with solving that polynomial? So you can solve a polynomial by factoring and taking those values you find when factoring and placing them on the number line. You can solve it by taking the square root, that we call that the undoing method. So like you're finding the values the same way, it's just we're using those values a little differently compared to it being an equation. Any questions? Okay, so I'd like you to take your calculator out because the next one deals with the calculator. Just to get you to think of how it looks in the calculator, what you're looking for graphically. Sometimes it helps pull in that graphing feature so we can see like a picture of what we're really trying to solve for. So this one says to use the calculator to approximate the values of x that satisfy the fact that y is greater than or equal to 1 when my equation is y equals 1/2 x squared minus 2x plus 1. Now in the calculator, we're going to plug in two things. We're not doing any solving. We're not trying to get x by itself. We're not trying to solve for something. We're going to graph both of these as separate equations. So we're going to graph the y is greater than or equal to 1. We're going to place that in for y1. We're going to put in the quadratic equation in for y2. So you have to think, like you're still graphing two separate pieces. we're going to get the calculator to shade for us to show that our y1 is greater than or equal to 1, so that I can have all of the values of the graph that are above 1. So if you take out that calculator, go to the y equals and see if you can plug this in. And once you get your calculator kind of plugged in there, get those equations plugged in. See if you remember what you need to change. So I have first one, y1 is just 1, and then my second equation is the quadratic. And remember, our goal is to show that the y is greater than or equal to 1. So I'm going to go to my equation for y1 where that 1 exists, and that's the part we're going to change because I want it to be greater than or equal to 1. That's the part we're shading above. So I went to the left of the y1, and I'm going to hit enter to start to change the shading of that line. I no longer want it to be a line. I want it to be above the line or greater than the line. So if you hit enter again, it changes that shading so that now it looks like we are going to be shading above the line so that it's greater than or equal to 1. So anytime you're given a number and it's greater than that number or less than that number, you're going to be shading with that horizontal line. So I'm shading either above the horizontal line or below that horizontal line, not the parabola part, just the horizontal line. So when you hit graph, there's my horizontal line shaded above, there's my parabola. So where would the solution be? What area of this parabola are we looking at? So where's the solution located in my picture? Or my calculator screen, I guess it's not really a picture. Cassidy, do you know where the solution would be? Like what area are we looking at in this graph that we have drawn in the calculator?
It would be anywhere on the parabola that's shaded.
Yeah, anywhere that's shaded in the parabola. So if it's not shaded, it's not a solution. So that would be these two like arms of the parabola. We're going to call it arms. This part on the left, that curved piece on the left, the curved part on the right. And this one's really nice because the graph came out clear. You can see that it's obviously intersecting at the x value of 0, and it's intersecting at the x value of 4. Remember, we're still solving for x, the inequality. We still want to know what x is. If you're not sure where they intersect, yesterday we talked about doing that. Sorry, wrong button. And let the calculator figure out what is going on with it or where they're intersecting. So the last part, once you kind of isolate that area we're looking for, the last piece of this is to then describe the solution. What's the interval going to look like? So I'm going to go back to my iPad screen so that we can write this out.